Okay, so for this first problem, um, some of you had more trouble with it than I thought you would. And part of the reason why that was you were getting confused with the adding part. And a lot of you thought that you needed to do this first. So I heard a couple people say, oh, in BEDMIS, you have to add before you subtract. So if BEDMIS is new to you and you're in grade 5 and you haven't heard that, then you'll get there. And if you're in grade 6, just to clarify, when in BEDMIS there's a D and an M, and when there's an A and an S, just because the A comes before the S does not mean that you have to add before you subtract. These are actually considered equal, and as are the D and the M. And so the way that it works is you do brackets first, exponents first, then you divide and multiply in the order that they're written, and then the last thing is you add and subtract in the order that they're written. So that confused a few of you. The other thing that I wanted to mention was up here. Whoops, I'm trying to erase that. There we go. In fact, this is not 935 plus 868. It's actually negative 935, or subtracting 935 and then adding 868. So that's the other piece to think about. So one of the ways to approach this question is to notice right off the bat that this 935 and this 265, a 35 and a 65 together make 100. They're friendly numbers. So what you're really doing here is you're taking away 900 and you're taking away 200, and then you're taking away the 35 and you're taking away the 65. So what I actually just did was I did 900 plus 200 plus 35 plus 65. That makes 100. So this is really just 1200. Then I looked at these numbers, which also happen to be friendly numbers because 32 and 68 also make 100. So I did 700 plus 800 plus 32 plus 68. This part makes 100. When I added that, I got 1600. Then all I did was I knew these green ones were negative because of this, and I knew the red ones were positive. So I just did 1600 minus 1200 and got 400. So one of the big things that I noticed in your work, a lot of you just tried to stack and add these or stack and subtract. You need to break out of that and you need to look at friendly numbers. You need to think about mental math strategies and how to quickly compute things in your head, trying to make the numbers more friendly for you. Let's look at the second one here. So a couple of the things that were challenging with the second one. A lot of you were stuck on this word counting number. My advice to you on a contest is if you come across something that you don't know, either like ignore it and try to do it if it just said number and see what happens, or just think about what do I think counting means. So if you thought about it, counting, when you're counting, you say 1, 2, 3, 4, etc. Those are counting numbers. So counting numbers are whole numbers. So they're not decimals, they're not fractions. They're whole numbers that start not at 0, so because whole numbers are 0, 1, 2, 3, etc. Counting numbers start at 1. That's the only difference between a whole number and a counting number, is that counting numbers don't include 0. So the other thing that some of you got stuck on here was the increasing order. That means from left to right, they have to increase in order. So for example, the number 1, 2, 3, that increases in order. But the number 3, 2, 1, that decreases in order. So that sort of messed up a few of you. Let's look at some of the other hints. So to be a multiple of 15, you have to end in a 0 or a 5. That's the only way to be a multiple of 15. And then you have to realize that, hey, wait a minute, I can't end in a 0 because my last digit has to be the biggest to be increasing number or increasing order. So I have to end in a 5. So I have to have something, something 5. And then it says the sum of the digits is 9. So if I already have a 5, that means I must have these two here, this digit and this digit, must add to equal 4. Well, I could have 2 and 2, or I could have a 1 and a 3. I can't have 2 and 2 because those wouldn't increase. So I have to have a 1 and a 3. And so my only option is 135 to be able to fit those clues. All right, this one was a bit of a tricky one. The first thing that you had to realize here was when it talks about even digits being removed. So for example, the number 12, you would remove the 2 because that is an even digit, but you would keep the 1. So you don't just remove the even, like 12 is an even number, but within the number 12, the only digit that is even is the 2. Whereas in 22, you would actually remove both of the 2's. And the other thing to think about is a number like 25. That number is an odd number, but this is an even digit. So you would remove that 2 and you would keep the 5. So with these questions, I did notice some of you writing out all 100, well, all of these numbers, 10 all the way through 99. You wrote them all on your paper and you crossed out all of the even digits. Totally works. It just takes a really long time. Now, this contest tends to be one where you do have a decent amount of time to answer each question, but there are other contests that you will face where you don't have a lot of time. So we always have to think about a strategy. So the way that I approached this, so the first thing that I did, oh, by the way, before I say that, a lot of you thought about 0 and what to do with 0. So is the number 10 an even number? Why is it an even number? Because it ends in 0. So 0 is considered an even digit. So what I did was I broke it down into the units place, and I broke it down into the tens place. So I knew that in the units place, if it ended in a 0, a 2, a 4, a 6, or an 8, it would need to be, I would need to get rid of it. So as you think about all the numbers, so from 10 to 19, from 20 to 29, and again, if you think about a pattern, this goes 40s, 50s, 60s, 70s, 80s, and I run out of space, but 90s. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 of these. And the behavior is the same. From 10 to 19, I'm going to remove the same digits in the unit place as I would from 20 to 29, etc. So let's look at 10 to 19 as an example. From 10 to 19, I would remove, in the units place only, the 2 from the 12, the 4 from the 14, oh, sorry, I missed it, the 10, the 0 from the 10, the 6 from the 16, and the 8 from the 18. There are 5 numbers that I would remove, but I would remove 5 from this group, and 5 from this group, and 5 from this group. So in total, I would remove 45 digits. Now, look at the tens place. Tens place is a little different. In the tens place, if these are my groups here, numbers from 10 to 19, 20 to 29, 30 to 39, I'm going to have to remove all of the 20s, all of the tens place, the 2's from the tens place. I'm going to have to remove all of the 40s, all of the 60s, and all of the 80s. Now, when I look at, say, 20 to 29, how many 2's are in the tens place? Again, if I went through the numbers from 20 to 29, you might initially think, oh, there's 9 numbers, 20 to 29, there's 9 numbers. But if you counted it out, there's actually 10 because 20 counts as one. So if you go 20, 21, 22, okay, you're going to get to 10 numbers. So there are 10 2's, there are 10 4's, there are 10 6's, and there are 10 8's in the tens place. Remember, I already dealt with the units place. That's 40 digits that I would remove. So I'm removing 45 here, and I'm removing 40 here. I'm removing 85 digits. That's what I'm removing. So that means if there's 180 digits in total, and I'm removing 85, I am keeping 95. So that's one way of approaching it. The way that I did it is actually different when I read the answers. It's different than how they did it in the answers, but for me that worked easiest. It was a strategy to follow. It's a little bit more efficient than just writing out all. So this one here, again, people were a little bit confused by the word counting number. We've now dealt with that. We know that it has to be 2 digits. So the highest that we can have is 99 and the lowest that we can have is 10. So what you have to think about here again is the clues. So the multiple of 5, it has to end in a 0 or 5 to be a multiple of 5. So to be one more than a multiple of 5, you need to end in a 1 or a 6. So one of the ways of dealing with this is just to start to write down some of the 2-digit numbers that you can think of in a sequential order that end in a 1 or a 6. Now, what you're going to notice right away, and maybe you should notice this before you start writing these, it has to be 1 less than a multiple of 4. So let's talk about multiples of 4. 4, 8, 12, 16, 20, etc. To be 1 less than a multiple of 4, 3, 7, 11, 15, 19. What do you notice about all those numbers? They are all odd. So that means right off the bat, we know we have to end in a 1 or a 6. We're not going to end in a 6. All of these are gone. So really, you can now narrow down your list into all of the numbers that end in a 1 that are 2-digit numbers. So we know it has to be one of these. So now the question is, what is the smallest one? And we know finally that it has to be a multiple of 3. So the divisibility rule for 3 is that to be a multiple of 3, so if we look at that, 3, 6, 9, 12, 15, 18. So here are some multiples of 3. What you notice about these, when you add up the digits, so I guess I should skip those because they're not 2-digit numbers. 1 plus 2 is 3, 1 plus 5 is 6, 1 plus 8 is 9, 2 plus 1 is 3, 2 plus 4 is 6. They always end up adding to something that's a multiple of 3. So let's start to look at that. So when I add 11, 1 plus 1, I get 2. That's not a multiple of 3. 21, 2 plus 1, I get 3. So that could be a possibility. 31, that's 4. 41, 5. 51, 6, that could be a possibility. That's 7. That's 8. That's 9. That could be a possibility. So now I'm down to 3 possibilities. Now remember, I had to be 1 less than a multiple of 4. So a lot of you said 21. But let's look at the number 21. Is it 1 less than a multiple of 4? No. 51, however, 48 is a multiple of 4, 52 is a multiple of 4, 51 is 1 less than a multiple of 4. It's actually 51 that's the answer. Okay, this final one here, it was definitely confusing for many of you. So the idea here is that you're just, like, you have these bricks that are like 3 by 3 by 2, and you're trying to put them inside that. And the question is just how many will fit in there without it overflowing, without it going higher than the box. So a couple of you used a strategy of like, I'm just going to find the volume of the entire box, and I'm going to find the volume of one brick, and I'm going to figure out how many of these go into this. So this was 18, and I don't know what that one was off the top. I don't have a calculator. I'm not sure what that is, just quickly off the top of my head, but you figured out how many times does 18 go into that. The problem with that strategy is these are a distinct shape. If it was a question like you had a brick of sugar that was that size and how many would go in, or a scoop of sugar that was that, so you had a scoop of sugar that was that size and how many will fit in. This strategy would work because sugar or water or something like that, once you pour it in, the shape changes and it fills in the holes. this shape is not going to change when you put it in. So unfortunately, this volume strategy isn't going to work. So the best way to think about this is to draw out, here's my 13 and here's my 8. Here's my base. Think about how I can arrange these 3 by 3 by 2 bricks. So for example, you could put a 3 and a 3 and a 3. Oh, I didn't draw this well. Okay, let me try this again. I made them too big. So you can put a 3, a 3, a 3, and a 3 here. And that gets to 12. You're going to have one little space left over, but there's nothing you can do with that space. Nothing will fit into that space. So this is the example of what I was talking about with like the volume strategy. If it was sugar or something, it would flow into that space, but a solid brick, nothing's going to fit into that space. And then here's a 3 and a 3 and a 3 and a 3. And then you have to picture that the height is 2. And I can't show you that on the video, but picture like a pen coming out of the video screen that's too tall. So could we do another set? Yes, we could. Because here we've got a 3 and a 3. So we're going to have 2. So if we look at this, here's 3, 3. I'm going to have 2 left over. Can I do anything with my 2 left over? So that's the question. Up here, I could not do anything with the 1 that was left over, but with the 2 that's left over, I could put, and this is not drawn well at all, so definitely not drawn to scale, but these ones are 2 by 3. So all of these ones are 3 by 3. So I'm going to color them. I'm going to color them. Whoops. I'm going to color them blue. These ones are all 3 by 3. And then these ones here are 3 by 2. Because remember, you can turn the bricks any way that you want. So these ones are going to go taller. So now these ones, if you pictured like a pen coming out of the screen, these ones are 3 high. So it's like I'm putting the brick in. Here's my 2, here's my 3. They're going to be 3 high. The box is only 4 high. So how many of these can I put in? Because the box is only 4 high, I can put in 1, 1, 1, and 1. These ones, I'm going to be putting them in like they're this kind of shape. 3 by 3 by, oops, sorry, this is a 2. 3 by 3 by 2. So these ones are a little shorter. If the box is 4 high and these are 2, I can stack 2 of them on top of each other. So that means I can do 2 of these and 2 of these and 2 of these and 2 of these and 2 and 2 and 2 and 2. So in total, I'm going to have 8, 16, 17, 18, 19, 20. So I know that's maybe a bit confusing because I can't show you a physical brick, but that's one way to think about this problem. If you have any questions, come and talk.